Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe.
Problem 81. The velocity at the vena contracta of a 50 millimeter diameter orifice is 8.535 meters per second under a head of 4.575 meters. So part 1, 81.1, determine the coefficient of velocity. Then part 2, if the measured discharge is 11.42 liters per second, determine the diameter at the vena contracta in mm and the coefficient of discharge. So for the solution, uh, first let's compute the coefficient of velocity using the formula. Actual velocity V equals coefficient of velocity C sub V square root of 2gh. So V equals C sub V square root of 2gh, where V is equal to 8.535 and the head is 4.575. Substituting, 8.535 equals C sub V square root of 2 times 9.81 times 4.575. Solving for C sub V is equal to 0.9009. Then for the second part, discharge is given. To compute first the coefficient or the diameter at the vena contracta using Q equals area at the vena contracta times actual velocity. So that's the first way of solving for the diameter at the vena contracta, diameter of the jet at the vena contracta. So Q is 0.01142 and the area at the vena contracta is pi over 4 diameter square and V is 8.535. So 0.01142 equals pi over 4 diameter square times 8.535, where D is the diameter of the jet at the vena contracta. So solving for D, 0.04127 meter or 41.27 mm. The other way of computing the diameter is to solve for the coefficient of discharge first. From the formula, actual discharge equals Ka of tog. So Q equals coefficient of discharge, area of orifice, square root of 2g times the head. So this is the other way of solving for the diameter at the vena contracta. So we can solve for C first. 0.01142 equals coefficient of discharge pi over 4.05 squared times square root of 19.62 2g times head 4.575. So solving for C is equal to 0.6139. Then from the relationship C equals C sub V. So let's solve for C sub C first. C is 0.6139 equals C sub C times 0.9009. So solving for C sub C is 0.6814. Having known C sub C, we equate this to area at the vena contracta, pi over 4 diameter square over area of the orifice, pi over 4, 50 mm square. So instead of putting pi over 4, we cancel it. So we just use diameter square over 50 square for C sub C. So 0.6814 equals D square over 50 square. Solving for the diameter, it is also 41.27 mm. And we have already found C. Let's continue to compute for the coefficient of discharge, having found the diameter at the vena contracta. So let's solve for C sub C first. C sub C is diameter or area at the vena contracta over area of orifice. Since both these areas involve pi over 4, so pi over 4 is not written. We just use ratio of diameter square. So C sub C is 41.27 square over 50 square. So C sub C is equal to 0.6813. So there's a very, very small discrepancy, but it's acceptable. So having found C sub C, C is equal to C sub C, C sub V. So C sub C, C sub V, C is equal to 0.6813 times 0.9009. So C is equal to 0.6138. So there is a very, very small difference, but that is acceptable. Problem 82. Oil flows through a standard 25 millimeter diameter orifice under a 5.5 meter head at the rate of 3.140 liters per second. The jet strikes a wall 1.525 meters away and 120 mm below the center line of the contracted section of the jet. What are the values of the three orifice coefficients? So these are C, C sub C, and C sub V. So for the solution, first, knowing the actual discharge, we can compute for coefficient of discharge from the formula Q actual discharge equals K of tau. So C area O square root of 2G big H. Substituting 0.003140 equals C pi over 4 times 0.025 square times square root of 2 times 9.81 times the head, which is 5.5. So only C is the unknown in this equation. Solving for C, C is equal to 0.6158. Then by the data on the trajectory coordinates, so we use the formula which I derived, x squared equals 4c sub v squared head times y. So x squared equals 4c sub v squared head times y, where x is 1.525 meters, y is 120 mm or 0.12 meter, and the head is 5.5. So from this equation, we can solve for c sub v. Then knowing c sub v, C equals C sub C, C sub V, then we can solve C sub C at the last part. So substitute 1.525 square equals 4 times C sub V squared times the head, which is 5.5 times Y, which is 0.12 meter. Solving for C sub V is equal to 0.9386. Then for the last C sub C, from the relationship C equals C sub C, C sub V, where C is 0.6158, so 0.6158 equals C sub C times 0.9386. So solving for C sub C is equal to 0.6561.